It's joining us today to talk to us about Cashmere testing and answer any questions that we may have. So with that, I'll hand it over to you, Reed. Thank you.
Sure. I'd like to kind of just give a little quick kind of background and synopsis of kind of where we're at with the lab and myself. I serve as the center director, and I have for the last 3 years. And then prior to that, I've been here at the research center for 8 years as an extension specialist. And we're moving through a transition period here at the research center and at the Bill Sims Woolley Mohair Research Laboratory. Farron Pfeiffer, who had basically was here when the lab was built in the mid 80s, finished his career and retired in August. And so he'd been the main person in the lab for 30 plus years. So he's retired, and we've been into a transition period. And to really add to that transition period, the lab has also expanded our services. We've always provided individual grower testing.
Computer sound over the whole.
And that's been to a variety of fibers, whether that's wool, mohair, cashmere, alpaca.
There's a computer sound thing.
And then in May of this year, the lab be able to get a little bit of feedback to provide commercial core testing services. And that's really been the main focus of the lab, to be able to provide testing of wool cores so that America has a domestic laboratory that can provide quality and quantity characteristics of wool cores, and that sets the standard for how those are sold across the United States. So that's been a big focus area, and so I apologize, some of these things haven't been as quickly as we would generally like to in a lab, but we've got new people and we had a new service that we really had to stand up. And so before, Jolene Frost, who's a student worker, had been mentored and trained by Farron Pfeiffer to provide a lot of the individual testing. And Danielle, I believe, she had worked with you quite a bit, receiving the samples, having them analyzed, sharing data, and all of those things. She has moved on to a different position. And so Vamshi is taking over the coordination of those individual grower tests as well as our other testing as well. So I'm not exactly sure what all things you'd like for me to cover today, Danielle. Not Danielle. Yeah. So and kind of touch base on. We can go through some of the data that we had shared and kind of how we analyze that. Take a look at it. I know, back in the spring, about probably this time last year, the conversations were starting, and it really, from an efficiency standpoint and consistency with what we do, a lot of other individual grower testing is using our OFDA 2000 in the staple mode, where it's greasy samples that are run. That's a very efficient test. It's pretty inexpensive, but I know there was concerns with the accuracy of that. So the lab also has a couple of other instruments. So we have the OFDA 100, which I think maybe have been the main piece of equipment that the Cashmere Association, correct me if I'm wrong here, has been accustomed to, and accustomed to using with Angus McCall and the Yoakum McCall laboratory. So we have one of those, but it is 20th century technology, and the components of it to be able to measure wool, the laser part of it, still work, but it's the software and all of the other components that fit with it that are a real challenge to keep going and moving forward. It's why we kind of looked at doing the OFDA staple. We also have another piece of equipment, the OFDA 2000, that runs in a snippet mode. So the fibers are cleaned and put on a slide, very similar to the OFDA 100. And that piece of equipment, I'm going to show some data here in a minute. I suspect you want me to kind of show some of that work that we did. Maybe makes a more accurate prediction, or at least it's more consistent with the OFDA 100. But unfortunately, since we've communicated last, we're starting to have some of the same technological issues with that piece of equipment. The computer's old and they crash because you can't update them, because every time you update them, the software that's used on that becomes incompatible with newer versions of whatever operating system that's working on. During that time, as we've stood up the commercial side of the lab, we rely heavily on our laser scan, which now has been upgraded, improved, and we're running hundreds of samples through that a week. And that's really kind of the gold standard in our lab and a lot of other labs as well. So throughout this, I might open the discussion to looking at that piece of equipment, because we use it in another service. So it's constantly going, constantly running, and operating there. So I guess I didn't start with, thanks for being here. And as our lab, we're really excited to work with your association. We really hope that that we can provide a service to the association and create a partnership to where if you all see things that need to be improved upon and grow with, that we can provide that service. So Vamshi, do you want to add anything here? He's our lab coordinator, the guy that most people are communicating with, that receives the samples and you'll get reports from, so on and so forth.
Firstly, I'll introduce briefly about me. My name is Vamshi, and I'm working as a wool lab coordinator here at Bill Sims Wool and Mohair Research Lab. I've been working past 1 year as a wool lab coordinator, communicating with the clients and coordinating with Reed and our lab staff, keeping up the lab running with the quality and the consistency of the lab, with accurate results delivering to the clients. So yeah, as far as last time we spoke with Daniel regarding the Cashmere test, which we have done and processed, that we have discussed the data, which looked pretty consistent, and we are pretty confident about the results as well. As Reed added, we would like to serve Cashmere Goat Association with accurate results and deliver them on time.
So Danielle, where would you like to go from here? We can take some questions here. I will be completely honest. I've spent my majority of my life's work around sheep and goats, but not a lot of that has been around the Cashmere goat. And so I'm not going to lead you falsely to believe that I know a ton about the industry and all the ins and outs of it. And look forward to answering questions and discussing with the group and learning as we go here. So,
sure. So maybe a good starting point. I know you went over the difference between the OFDA 100, the 200 in snippet mode, and then the 200 in staple mode kind of very quickly. But maybe if, I appreciate for people that don't deal with this regularly, that's kind of a tricky concept. So maybe if we could take a step back and kind of go over each one, the old OFD 100,
okay.
how those samples are prepared, and then its equivalent in the OFDA 2000 snippet mode versus the staple.
Right.
If that's okay.
Right. Yeah, sure. So the staple mode is, samples will come in and they're basically taken raw as they are, and they're put on a plate, if you would, and that plate has two sides to it, and it's got slits in the middle. So you lay that sample from the shorn or maybe a cashmere combed end of the fiber, and then you lay it all the way down. And so then that laser, and we can probably share some videos of it, goes through and then measures that fiber greasy. And then there's going to be a grease adjustment factor that's built into that, based on kind of a known amount. So there's a certain amount of them that are washed, and so we can create a grease correction factor across a sample type, but that's generally not done on each individual sample. I don't believe that that's as big of a concern. There's not as much grease I believe, in cashmere hair than there would be with wool, for instance, that has a ton of lanolin on it, and there's more variability there. But there can be other things as well. And so that fiber goes down, and then you would get a report of the average fiber diameter across the length of that fiber. You'll also be able to get a histogram, so you'll be able to see the fiber diameter along that fiber. And then it can also give, things like coefficient of variation along the fiber, and comfort factor and things like that, which are generally measured as the number of fibers over 30 in wool. If that's something different in cashmere, I'd be keen to learn on some of those things. But that's the FDA staple. So it's a test that can be run in just a couple of minutes for each of those. There's not a lot of lab work that goes along with it. The 100, the FDA 100 and the FDA 2000 snippet mode operate about the same. So those samples will come into the lab, and then they're going to be cut with a guillotine. So that guillotine is basically taking small little pieces, that are I guess, were they a couple millimeters in length, and they're chopped up into small little pieces, and then those fibers are then going to be washed. They're pre-washed, and then we chem wash to get everything off of them. That's going to be dried, and then there's a little device, and I wish we had a video here. I apologize for that. Where they're going to be put in, and then there's another little device that kind of moves them around, scatters them around. They fall through holes to get onto a slide where they're evenly dispersed. And then that slide is the same slide for an OFDA 100 as it is the 2000 snippet mode. It's placed on a piece of equipment, and it does the same thing and scans across a glass side to be able to predict those. It tends to be a little bit more accurate because you don't have any other things on there, grease, dirt, whatever can be stuck to the edge of that fiber. The downside is that's then just put, is all the preparation that goes into putting that. Plus, we're working with, 40, 50-year-old technology. So again, the software functions that support all that become a real challenge. So those operate pretty much the same. And then the laser scan has some similarities in the sense that we are going to guillotine it and get it into a small little fiber. So it's going to be cut into small little pieces. It will be washed similarly, but then segments of that are dropped into the laser scan that has a fluid, and then that fluid runs across the laser. And so it looks a lot different. We don't put them on a slide, so we don't have to put the slides down and label those. They just get washed in chronological order for, keeping the nomenclature of the samples in order, but they run the same, but they are cleaned. So hopefully that helps, and I didn't ramble along and confuse people too much there.
Yeah, so just to add to that, if you had samples run before at Yoakum McCall, that was done on the OFDA 100.
Correct.
And if you were to do a test at TAMU now, so the $5 test is the staple mode on the 2000.
That's
if you go for the $15 test, people tend to say $15 test, $5 test.
Right.
If you do the $5 test, it's the OFDA 100.
That's correct.
Or the staple mode. Okay. I have a question from David. What is the correction factor between greasy and washed for cashmere?
I'm not sure. We will have to pull that out. Jolene is the one that did all of those this spring, that would have established that. And I can't say for sure.
Right. Thank you.
Vamshi, do you happen to know?
Well, I'm trying to find out now. I'll get back to you once I get it.
Thank you. So I don't have any other questions popping up if you want to do you want to discuss data or?
Sure. I like data.
Me too.
Okay. Can you all see the screen here?
Yep.
Okay. I'm looking at my second window, so you're going to be looking at the side of my head as I turn over here. But so these are the samples that were run earlier this year. So there's, let's go back and see. So there was 50 samples that were analyzed. And we ran them on the OFDA 100, the 2000 snippet mode, and staple. And we're kind of looking at the 100 as the standard, if you would, because that's what you've all been accustomed to seeing. And so this graph here shows the OFDA 100 on the y-axis, and then our x-axis is the 2000 staple. So each of these blue dots would represent a sample that was ran on both. And so, and then we have, a linear prediction here and an R-squared. And so the two things you really want to kind of focus on is the R-squared gives us the relative prediction. So are they the same? So are we predicting, one or the other each time, and there's not a lot of variability? What we would like to see on R-squared, of course, these vary for different tests that you want to look at, but the closer to 1, the better. So at 0.86, it's basically saying that the two samples, have an 86% correlation, meaning that the majority of them group around that line, but you have some that are a little further away. So if you want to look at the one that's probably the furthest away, it's probably this one here, where the OFDA 2000 was calling that 17.6 micron, whereas the OFDA 100 is 15.7. Okay, so we're seeing almost a 2 micron difference in that one. The majority of these are grouped pretty close to the line. The second number you want to look at is right here in this linear prediction, this 0.93, and that's the slope of the line. What you want to see is 1 there, meaning that it's not changing, where it's really good at predicting micron when it's down here around, say, 15 to 16 micron, but it's really off one way or the other once we get to coarser micron fibers. Does that make sense? That's not too heavy in statistics, but it's kind of an easy way to just digest this. And so again, the scale, if you blow up the scale, you're going to see bigger dots, or we could have, shrunk the scale down and it looks like the blue dots are closer to one another. But for the most part, they're following the same linear line, depending on what the goals of, your breeders are. If your goals are finding those animals that are on the high end versus the low end, this is a very appropriate test. It's a good return for the cost that you have into it. But the more finite that you want to get these samples, it may not be the test that you would desire. So if we scroll down and look at the OFDA 100 versus the OFDA 2000 snippet. So I'll remind you that the snippet is the $15 test. It's the one that we have to wash and clean and slide, and it takes a lot more labor involved to get these results. And you'll see that there is a much more closer association between 100. So, before the R-squared, which is the relative prediction, I'll scroll back up here. Try not to do too much scrolling around and make you sick like you're watching a whole movie. But is 0.86. Down here is 0.99, and it doesn't take a PhD in statistics to realize that those are closer to the line, and then that linear line is at 0.96. So it's not 1, but it's pretty close. So, where it's going to cross 0, which doesn't mean a lot here, is 0.78. But, this one is going to give you a more accurate prediction of, when you're looking for something that's similar to the OFDA 100.
So we have a question. We have somebody just starting out with cashmere goats that has a small herd. They're curious about the basics. So one, which testing method is recommended? And I think, Reed, you kind of just answered that. If you want very, very precise data, it may be worth going to the $15 test.
Mm-hmm.
But if you're just looking for getting a general idea or ranking,
yeah,
the less expensive test may be. But perhaps you can also share with them a way they can have testing done for free with the Langston study.
Okay. You're probably more aware of how that study operates than I am.
Okay.
They communicate with us and they send us bulk samples and we run them and send the results back. And that's the extent of my knowledge of that program.
Oh, I'm happy to talk about it. I just didn't want to steal your thunder there. So on the Cashmere Goat Association website, we could put a link in there. So basically, if you'd like to participate in this study, they're looking at genetic association between different cashmere goats from all over the country and abroad, looking at the differences between diameter and a few other factors that they're evaluating with their genetics. So if you send some guard hair fiber samples, and there's instructions on how to do this along with a fiber sample, cashmere sample, they will send the sample to Texas A&M to be evaluated for on one of these for diameter and a few other parameters that they're looking at. And then they'll use the guard hairs that you collect with the bulbs at the end to extract DNA and then run a genetic analysis on this. So that's one way that you can actually have this testing done for free. And we'll put that link in there, but lots of good detailed instructions on how you could participate for free. And then the second part of the question there was, how does this impact getting our goats registered? We do have a cutoff for registration. So if you are, I would say, maybe close to the higher end in diameter, maybe you want to go with the snippet test, the more expensive test. But either test can be used to register your goat. A question from Christine. The research by Langston is being done with the 2000 snippet mode to confirm. The laser evaluation seems like a new process for us to hear about. Has any research been done comparing the 2000 snippet results with the laser evaluation?
That is a great question. I have not scoured the literature on that, but one of the thoughts that I had for this meeting is if that's of interest, we might run a similar thing that we did here and use the laser scan as another means. As the lab, we're happy to provide services, but we also want to be able to deliver on those services in a timely manner. And so one of the challenges is, and I'm like everyone else, I don't like change all that time whenever I have to find something that works. So I understand like the interest in sticking with the OFDA 100. And we can generally call in Farron. He's retired, but he's still here locally, and we'll come out and help when we need to get something, up and running whenever we have a bulk of samples that come through. But if it's a challenge to keep this going and we're calling him every week, or something major goes down with this, we're trying to figure out how we have something that's a bit more reliable because we're using it for other tests. It's a commonly used product because we just don't run the OFDA 100 that often. On a few cashmere samples and some Angora samples that we get from time to time. But it's something that's that worries me, being able to go if everyone wants to stick with that one. Whereas the laser scan, I believe we can get just as accurate as the results. But I'm much more confident that service is there and it can be done in a timely manner.
What's the price points on the laser scan test?
The laser scan is a $12 test. There is still some preparation in the sample. It's less expensive than the OFDA Snippet 2000, but it's not quite as inexpensive as the OFDA 2000 staple mode because of all the prep work that it takes to get those samples ready to run across the machine.
While we're on the topic of the laser versus the other test, David has a question about what is your view on other attributes like modulated fibers on the 100 versus 2000 versus laser?
So that's one of the advantages the OFDA 100 is it can measure modulated fibers at a better degree than the other pieces of equipment. I guess my question would be, what is the value of that modulated fiber percent to your association, to individual breeders? How important is it?
David, would you like to comment on that?
Yeah, I'll get the video up here. Yeah, like we're going through the process at the moment of trying to obviously get a test that is able to be commercially viable on large numbers of commercial animals. You know, when you're getting in the tens of dollars, you then only pick your stud animals to test. If quite a bit of the cost is associated with someone standing by the machine as much as actually running the sample through the machine. So it's getting all those compromises together. And some of the merino people in New Zealand here that are doing straight staple tests are getting it for around $2. Like it's very simple, very quick, and they're only after a few attributes, micron and CV, pretty much. But as these samples go through the machine, you can capture a lot of the other information. The modulated fibers in airflock between probably 0.1 or 0 basically and 1%, that kind of range. Are they significant? Yeah, you know, as far as a D-head to a processor manufacturer, yeah, I'm interested in everybody else's views on those types of things. You know, the main emphasis obviously is about stability in micron and probably length, and then the attributes that come out of that, like curvature and those things.
Mm-hmm. Yeah, I mean, the reason I asked that is, I mean, it's not a loaded question because I don't know for Cashmere. I am really familiar with modulated fibers and Angoras. You know, Texas used to have a very large population of Angoras. It's pretty small now, but we still work with a lot of breeders, and they are really on to us about selection for modulated fibers, and we go through the animals and pick them out, and they're very concerned about it. But when we run that on the OFDA 2000, and these are core samples from fleeces, not side samples, because most of that modulated fiber in an Angora goat is typically coming from the top of their head or right down the middle of their back. And so we run those samples and have that done from a core, and those are done on the OFDA 100, but they come back at like 0.5% to 1%. Which, you know, when I talk to the processors, that's of no concern to them at those lower values. But when we started an Angora test 35, 40 years ago, those modulated fibers were coming in at 10 to 20% of some samples, which is a big concern for the processors. And so through genetic selection, they brought it way down, and we, you know, wouldn't want to get complacent and let that problem jump back up, but it's quite low. And so is that a major concern for cashmere that's being harvested and marketing those medullated fibers?
Yeah, I don't know directly. Like under the international standard for cashmere is less than 2% of hair. So as long as you're well under that, medullated fibers still pass obviously the longer the better. There's many other attributes in the fiber that are more important. The issue here is share most of the animals, and the Australians have developed an objective yield test that goes associated with the sample test, and so you guys have a cut of less than 30 microns for cashmere. The Aussies have a test that for cashmere is under 35, but the 35 then is useful for calculating the percentage of guard hair in the fleece versus the amount of down.
So the our 30 is it can be adjusted. So that's a number that we could change to 35 or 50 or 60. So, that one can be, changed to where you're only getting an average fiber diameter of those that are less than 30, or you can move that number around. It's not static.
But you want it static, otherwise the tests are hard to be relative between farmers and years and things.
Mm-hmm.
So yeah, so it's either one or the other. I'm currently on 35 with their testers, but I think that's only Australia and New Zealand. Everybody else uses under 30.
Yeah, I would agree. I don't think it would be wise to be changing that between growers, but if an association wanted to change that number, I guess that's what I meant by it's not a static number. So
there's only about 1% of fibers fall between 30 and 35 generally. Yeah. Anyway.
And I see in the chat, Vamchi provided the grease correction factor. For the study that we sent in those 50 samples, it was 0.3 microns, but they said they also have a few cashmere samples in the lab, which range from 0.3 to 0.6 microns.
thank you, Vamshi. What I'm kind of eager to hear back from the group is given the data that was presented today, and Daniel, I believe you may have shared that around, so people had a chance to review it ahead of time. Is there a strong interest in sticking with the OFDA 2000 snippet mode? Because our computer crashed, and that runs that piece of equipment, and it's not something that we provide a service to a lot of other fiber types. And so we can purchase a new computer. We can repurchase the software from Australia, have it reinstalled and get it up and running again. But if there's a stronger interest to determine if the laser scan, which would probably be a more reliable instrument going forward, would meet the needs better of that accurate, $12 test, not a $15 test, then maybe instead of us bringing that back to life, would be to do some trials to see if the laser scan can get similar results to our OFDA 100, and would be a preferred strategy or preferred test.
My thought, and I don't speak for everybody, but I would like to see maybe a similar comparison to what we ran with the 100 versus the 2000 and snippet and staple mode, and see that data, and also maybe have a chat with Langston and see if they're comfortable with changing the instrument for measurement partway through the study.
Okay.
But if anybody else has any thoughts,
Peter has a question that he's put forward a couple times.
Maybe you're on mute.
No, we're on.
Sure. Do you have any feedback on that point before we get to his question?
No, it was just, he put it up a while ago, so he's gonna be backing up in the presentation a little bit. Go ahead.
I don't know if I can hear. Can you hear?
Yep, sure can.
Okay, so when you're presenting the snippet mode, and we're talking about medullated, in Cashmere, the medullated is generally the guard hair. So it is the guard hair. So what I'm wondering is how do you sample that? We've been at Texas A&M years ago when they were sampling on the snippet mode, watched how Chris Lupton did it and Joe David. And when you print that out as an MFD, there's basically, you can print that all as one MFD with everything you core sample. Let's just say you core it with a tool, and you take a wad of fiber that's sent to you and you core it. Another way of doing it is just picking out random fingertip samples and putting it in a jig and snippeting it. But I'm wondering how you display that on the MFD histogram, because if you display it all in one histogram, you're going to get a lot of medullated fibers or guard hair. However, the way we've been doing it traditionally, and I'm sorry, David, I couldn't hear it was just hard to understand what was coming from New Zealand, but it sounded like he may have been talking to someone similar, that what is presented on histograms that we've been using traditionally is essentially a logarithmic histogram, which means that, and I think you were talking about something like that, fibers under 30 are presented in one graph. And then when it gets higher on the end toward guard hair, it's a second graph if you want that. And most of us have never really cared much about what the guard hair histogram looks like, but they have never been mixed because there's two samples that have two different peaks. And so what we're not looking for is a composite of those two peaks, but rather only the logarithmic histogram of what would be considered the down, something 30 microns or less. There's a cutoff point. So maybe you can speak to that. David, you may have been speaking to that already. We just couldn't understand here in Maine what was coming across on the audio. So go ahead.
Yeah, we sorry if my accent's throwing you off a little bit. I'll try and speak slow. Our histograms are identical to what Reed is producing for you. The interest that we have here historically has been, there was a Angora influence to some degree in some flocks because of the history of the industry. And we needed to be able to make sure that we weren't getting what we call shiners fibers, which are kind of a mixture of mohair type, very fine fibers showing up in the cashmere. By and large, we don't see them very often, but they're still through on the odd eagle, and particularly in foundation flocks that are using wild capture goats, because there's an element of that genetics in their background. So, so from a breeding point of view, we're just obviously trying to identify if there's still an issue in a problem, and then exclude the extreme animals that pop up and show up from time to time from any breeding programs, really.
What's the guy's name for Texas?
David, what's that?
From Texas A&M.
Reed
So
Redden.
what do you do? Or are you from Is he from Texas?
No, read and read, yes.
Okay, from the Texas A&M lab, what do you do? How do you sample the cashmere, a dual fibered animal? And then what do you do with the guard hair in that histogram, which are the medullated fibers generally?
So the majority it is, if you have that 30 micron cutoff, those are going to be excluded from the histogram for your mean fiber diameter. And if in the past you've gotten a second histogram for those above it, it's probably giving you a report of what the micron profile looks like for those that are cut off and measured above. And I think that's probably not of large interest to a lot of people because you're trying to select for finer of the cashmere, not finer of the guard hair. But that's going to be like, how do we handle that is going to be different by each test. So in the OFDA 2000 staple mode, where you're not washing or cleaning, you can just put those fibers on a slide and run it, and those guard hairs will be in there. There was some concern on this, and so when Jolene was here, we went through and hand-picked all of the noticeable guard hairs out of the sample and ran it again on the OFDA 2000 staple, because you run it and then that sample's there, you can see the long fibers, they're still intact, so they can be picked out. Ran them again and it didn't change the analysis any, which is what you would expect because it was supposed to be omitting those to begin with. That's not possible with the snippet mode, because those fibers are all chopped up into small pieces unless you picked them out before you chopped them up. But then now you're running, it's the same cashmere, but it's a different sample. And so you'll see some variability by just running a sample twice and with different fibers that come in the same sample set. Does that make sense?
Well, it makes sense. What I hear, what your 30 microgram or less is kind of the same that we've always thought of as a logarithmic histogram. So you're right. With anything over 30, we would discard that. We don't really care about that. And because it's a dual fibered animal. So you're really looking at what your initial spike is. And if your initial spike, if you're looking at a mean fiber diameter with a CV on it, it makes sense to just discard any medullated fibers or guard hairs on the right-hand side of that. But I'm not really so sure that why would you have to hand pick it? Hand picking seems like a pretty hard to standardize that process. So just forget hand picking. Why can't you just core or somehow have a standardized sample for the cashmere wad that comes in your hand, the cashmere sample that comes from a sample? So we're asking people to either shear it in a 2-inch block or comb it in essentially a 2-inch block. So you get a combination of fibers, some of which have a 25% yield, some of them have 50% yield, depending on whether you shear it or comb it. But it seems like you could just go ahead and measure that. I think that in Texas A&M previously, they were measuring it on what I thought was a laser scanner. There were like 5,000 measurements coming across, 5,000 measurements of snippets. But some of those snippets would have been guard hair. So the guard hair spike is over to the right, and it's basically discarded in a logarithmic. I guess what I'm asking is how are you sampling that? And it seems you're correct. I mean, just discard the medullated fibers or the guard hair fibers.
So
that you still get the same results from the down, which is the left-hand spike. Go ahead.
Yeah, we're not sorting them, and so those graphs are out of the same sample. It's not a different sample. The histogram is just cut off of the 30, and then they're separated into 2 histograms.
Okay.
So that we were doing that just as a kind of a trial and error thing. That's not a standardized thing that we do across all samples. We test whatever sample is sent to us. Now, your question of, could we core that? Yes, we absolutely can. We have a mini core machine that we use for other testing services, but it's going to require more sample to come in to do that. Vamshi, can you give them an idea of the volume of product that needs to go through our mini core machine to be able to get those cores to go through and get enough product for the test?
Yes. To use for the mini coring machine, we use approximate of 25 to 30 grams of the sample. So which will go through hand washing and chem wash, then it will go into mini coring machine. So how much volume would be appropriate for Cashmere, which I'm not aware of. So usually it requires 25 to 30 gram sample.
So that's a quarter. That's a quarter of a really good goat's production.
Yeah.
That's a huge sample. And what that in the old times, in the before times, when we were sampling from huge bags. And the problem was that you would, depending on how you sampled it, you could end up with neck fiber or Britchen fiber. There's 4 different fiber sites, and each of them generally has a different quality. So what was the problem in the past with these dots that are off the mean, off the straight line graph, was that they were basically sampling problems because you had a huge amount of sample. And so you could have been getting all neck, you could have been getting all Britchen or something. What we've tried to get people to do is go to a standardized place on a standardized goat with a standardized amount, which is a very small amount.
In the middle of the goat.
In the middle of the side, which is apples to apples.
Yeah.
If you're trying to evaluate an individual. So if you do that, you don't have to core it. I mean, not every lab we've ever sent to has cored it, but another way to do it is just pick it. Just pick enough to go in the jig to make your snippet work. It doesn't really matter how you sample it, as long as you don't sample a huge amount. But if you're sampling that much, you might well be having just a variation based on huge amounts of sites that are all of different quality. Try that.
Yeah, that's why we use the guillotine to do that, because most samples that come in across all fiber types that we run on the OFDA staple or snippet mode are 1-2 grams. So it's not a very large volume, and if we were to use that mini core machine, like I said, it would take a lot of sample to come in, which would be mini cored, and we would be able to return back, but those fibers are going to be cut when those cores are pushed through, so it's not going to be as quality as what it came in at. And then the snippet or the guillotine takes that small, maybe a quarter of a gram sample, which would be what we run on the OFDA 2000 staple. And so we took that same sample, the one that was run on the OFDA 2000, and then guillotined it. So the exact same sample was ran on both. It was not subsampled from whatever submission was sent into the lab. And the same slide was used on both the OFDA 100 and the OFDA 2000 snippet mode, the 2 separate $15 tests, to avoid that, avoid the noise of having what fibers are actually measured on the different machines be different because they're coming out of different pieces of the submission.
Okay.
I don't know if that answers your question or not.
Well, kind of. I mean, when you're snippeting whatever you got. So if you run it on the 2000 through a staple model, it really wouldn't have the same kind of result that a snippet would, right? Snippets are snippets. The staple looks at a fiber over 0.5 millimeter lengths or something, right?
Correct.
I mean, that's what you would use for a single follicle animal, looking at variations over the year and what his diameter looks like depending on feed weather, right? I mean,
Right.
the reason to do that, more or less.
It's maybe not the reason, but it's an added benefit of that test. So instead of, you know, let's just say if it was 18 micron mean fiber diameter in a snippet mode, and you looked at it in the staple mode, you might find out that that animal under good feed conditions would have been 20, but there was a period of the year where nutritionally they were stressed, and for 2 or 3 months it dropped down to 16 and got weak and then came back up. And so it does give you that profile to look at based off you know, nutrition, which is based on what they eat, but then also what they're producing. And so females, especially those that are, you know, lambing or kidding, are going to go through a stressful event even when you're keeping good feed in front of them, and so they tend to hold body weight or lose body weight. So you'll see that in that profile, that histogram profile, where it's along the fiber, not the mean fiber and how many fibers in each of the 0.5 micron categories.
If I may hop in, we have 5 minutes left. I know you guys are staying late at work today, so I don't want to keep you extra. Reed, you just kind of hinted on one of the questions that's been waiting in the chat for a while about, have you ever looked at the correlation in cashmere goats between feed content and quality and cashmere fiber quality?
I mean, I haven't. I've looked at that in other species or other breed types, and I would assume that it's probably similar. And so the way that we handle most of that is you try to only compare against animals within the same contemporary group. They're being fed the same, that, you know, you're not comparing, you know, one goat that, you know, had a set of triplets and raised them and one that didn't get bred. They're going to maybe genetically be the same, but nutritionally they're very different. And so likely the one that had triplets and grew that hair is going to be finer. And that's independent of their genetics. It's an environmental impact on their fiber quality.
And then one last question is from Christine. Are you aware of who else is measuring cashmere with the laser method? Universally, how is cashmere being measured in labs internationally? Is there communication with other labs in Italy, Australia, etc.?
We communicate mostly with New Zealand Wool Testing Authority and Australia Wool Testing Authority. They're basically under the same umbrella. And so folks with AWTA are the ones that do most of the service and help us with our pieces of equipment. That's where they came from originally. And, you know, recently we asked them if the laser scan would be an appropriate tool compared to how we traditionally been doing it. And their response was absolutely yes. That's where most of the first generation labs have gone to. That's their response. I have not done that survey, so if that's wrong, I'm not quoting that, not through my research, but what they had led us to believe.
And then one more question just came up. Is there a recommendation for feed for good quality of cashmere? I'm not sure you would know the answer to that, Reed.
Yeah, that might be a little bit outside my expertise. And if I did, I would take too much of your time and I may not be correct anyhow. So
I can recommend, perhaps if you're interested in cashmere nutrition, we do have on our YouTube page and also on our Cashmere Goat Association page, we have previous webinars, and some of them have focused on forage and some have focused on other types of supplemental nutrition. So Lasanya, you may find that valuable to go back. Cool. So I do want to keep you on time because I feel terrible you're staying late. But I guess for our next steps, we'll follow up within our next board meeting perhaps and discuss moving forward with the laser. And maybe we can connect offline and discuss what that may look like
Okay.
going forward, and also connect with Langston University and see how that may impact our fiber study that we're doing.
All right. Very good.
So with that, I thank you very much for always being willing to hop on a call, answer emails that we have coming from the CGA. We appreciate that we're only a very small percent of your customers, but we really appreciate all the time and energy that all of you put into helping us select the best animals and breed the best animals. We really appreciate it.
You bet. Glad to help.
Thank you all. Everybody have a great night. And if you haven't renewed your CGA membership, please make sure you do that. There's emails from Christine in your inbox to help you do that. Thank you, everyone. Have a great night.
Bye. Good evening.
Bye-bye.
Bye.